So what is AERSCREEN? For a long time, people have been using the Screen 3 model for all of their screening level air quality applications as part of their first step in a modeling analysis. Well, as of August 16, 2010, the EPA made a public beta release of the AERSCREEN application. AERSCREEN works alongside some of the existing AERMOD modeling system executables, and it produces estimates of 1 hour concentrations from a single source. There are also conversion factors involved, and so it will also produce estimates of 3 hour, 8 hour, 24 hour, and even annual concentration estimates. So you'll put in your typical source parameters, just like you would any old AERMOD run, for those of you who have done AERMOD modeling in the past, and it will automatically generate some receptor arrays and start doing concentration calculations using the same algorithms from the AERMOD model itself. AERSCREEN is built off of two main components. The first is the AERSCREEN executable, which handles primarily model input setup. The executable from the EPA is a series of DOS prompt questions that you can answer on your own time, and it asks you what kind of what source you want to use, how far out you want to analyze. You just answer a bunch of questions in a series, and it will produce your concentrations. It also, the AERSCREEN executable will also interface with the existing AERMAP, BPIP, and AERMOD executables. So if you're dealing with the EPA version, you've got to go out and make sure you already have each one of those executables on your computer so that you can then run AERSCREEN. When you're dealing with BREEZE, we make sure that everything is integrated into one package for you. The second main component of AERSCREEN is going to be MakeMet. Just as AirMet is going to read in raw hourly meteorological data and generate your SFC and PFL files, MakeMet is a bit more generic. It's just going to ask you for some basic site-specific meteorological conditions, and it's going to generate a matrix of those conditions so that it can produce some screening meteorological files. Now, the nice thing about these screening MET files that are generated by MakeMet is that not only can you use them with AERSCREEN, but you could then take them and use them in the AERMOD model itself to perform your own custom screening modeling analyses within the AERMOD application. So there's a lot of connections between what you can do with AERSCREEN and what you can do with AERMOD. The main difference is that with AERSCREEN, you're entering in some generic conditions to try and get a worst case scenario. What's the highest possible short-term or even long-term concentration estimate that the model could generate? And then if that value is above some certain limit, you can take it to AERMOD, refine a lot of your inputs, and make things a bit more refined and specific to your conditions. So the AERSCREEN model itself, you put in your input data, it's processed by the executable, there's some quality assurance checks that are performed so that all of the data is verified, and then it kicks off one of 3 routines, whereas AERMOD will look at each individual source's plume compared to user-defined receptors. The AERSCREEN executable, the AERSCREEN program, is going to auto-generate receptors based on these different routines. The first routine is called probe. When there's no source receptor direction dependency in your project, this is the routine that AERSCREEN is going to run. So in those cases, like you don't have elevated terrain impacts, you're not interested in building downwash on your point sources, or you're not running a rectangular area source, for example, then probe is what will be run by the model. And that simply places receptors every 25 meters, beginning from a definition where you say this is where the ambient air begins, so where your fence line is in relation to the source, and then it extends out as far as many kilometers as you want to input. The next routine is called flow sector. Flow sector is run when source direction dependency cases are present in your model inputs. So when you are accounting for elevated terrain, or if you do happen to have a building along with your point source or flare source, then you will see this flow sector routine run. Flow sector is going to go around each 10-degree wind sector, so 36 flow vectors in all, out to the user-defined distance, and it's going to process your process your results for each source type. The processing is a little different based on the type of source that you have. The rectangular area source in particular has a slightly different method to run the flow sector routine. But for the most part, you'll get a full circle of results for each of the 36 flow vectors. The final step then, regardless of whether probe or flow sector is run first, is the refine step. Refine is going to go through your whole matrix of meteorological conditions, and there can be a lot, because you can vary your met data by season, by month, or maybe one annual value, and you can also vary the met conditions by each of up to 1 to 12 surface roughness sectors. So you have a lot of different meteorological options, just as you would when processing data in AERMET for use in the full AERMOD. Refine then is going to take the worst case meteorological data or matrix that it generated, and then it will run a series of iterations on your receptors to find the specific down to 1 meter receptor where that maximum 1 hour concentration occurs. So if it knows there were high values between 50 and 75 meters for your receptor, automated receptor grid, then it will start drilling down every 5 meters, then every 2, and then every 1 to find that highest value. Some of the features of the EPA's AERSCREEN application, it can only model a single source. Although the source types are almost identical to what you could do with AERMOD, you have vertical, capped, and horizontal point sources. There's a flare source type as well, which is a modified point source. With area sources, you can have a rectangular or a circular shape, and then there's also a volume source. You can include impacts from building downwash and elevated terrain using the existing BPIP and AERMAP executables that are distributed by the EPA. You can also use your existing BPIP and air surface output files to define some of your input data. So rather than being restricted to the single building that AERSCREEN will allow you to input, you could specify an existing BPIP file that you might have done in a previous AERMOD project and use that to run all of your inputs off of. One other thing you may notice within AERSCREEN is that you never actually specify receptors to be added. Instead, the EPA generates automated receptor arrays to help identify where maximum concentrations may be occurring.
All and they can unmute themselves.
So let's start taking a look at what BREEZE has been working on. On the left there, you see a reduced sized image of the main input form for BREEZE AERSCREEN. We're going to take a little demo of it here in just a few minutes, but this is the basic layout of the program. You'll notice it has the familiar ribbon bar interface that has been integrated into a lot of our products, such as AERMOD and 3D Analyst and the brand new BREEZE Incident Analyst that we just released a few weeks ago. We have seamless integration of all program executables, so you're not going to be responsible for finding that BPIP executable or looking for the correct AERMAP executable on the EPA site. We're going to give you all of those executables when you download and install the program. The data entry forms are very simple to use. Those of you that are already customers of ours with the BREEZE AERMOD product will find it very similar to what you would input there. You also have multiple output formats, including charts and a table of output data that you would not get just running the EPA's version of AERSCREEN. Let's take a look at some of the more advanced features that we've added in here. The first is the Model Properties panel. This is brand new, and it is a really neat feature for being able to quickly add or check data that's already been input to your project. So this Model Properties panel will typically by default hang out on the left side of the program, but it is dockable. So you're able to pick up that panel, move it wherever you think works best for you. If you want it on the right side or the top or the bottom, or you just want to make it an external window and move it out of the way altogether, you can do that with this panel. It organizes the data logically as well. You can see we have building and control options, meteorology. Each of these options will define a whole group of inputs, and then each input is listed below, and you can manually edit the information that is presented there. Since all of the input data is summarized in one location, it makes this a great feature for quality assurance, quality control work. You can just quickly scan this Model Properties panel. You see every input that you put into the project, and you can quickly change things that you see might have been done in error. We also have the potential problem identification. This is a feature that a lot of our users have liked over the years since we first added it back in AERMOD, and we have kept it within the AERSCREEN application. With the potential problem identification window, it's still dockable, just like the properties panel, and it will only be displayed if you want it to be displayed or if an error happens to be present within your run. There's also visual indicators for the severity of the message. If you see the red X, that means you have a fatal error within your current run, and your run would not be successful if you were to attempt to run AERSCREEN at that point. A warning message, on the other hand, the little yellow triangle with the exclamation point, is something that you should be aware of that you may need to change prior to running, but may not necessarily prevent the model from successfully completing. There's also a location card here which tells you exactly where the message is coming from, and if you double click the message while running the program, it will take you directly to the input parameter that needs to be changed to fix the program. So it makes it very easy to identify where your project might be going south, where you might need to make some changes prior to attempting your model run. We also have enhanced model output that you would not normally get from the EPA's AERSCREEN program. We have multiple output formats available once a project is run. For example, the text reports, which have style editors, so you can change the font, change the color, select different regions. We also have a table of impacts, which is sortable by column, so you can see each of the receptors where AERSCREEN was calculating concentrations. It'll tell you where at that receptor when at that receptor it generated the maximum concentration. For example, if you had different seasonal or sector combinations. There's also chart displays, such as the example that you see here. This is a flow sector analysis chart. Now, it can be fairly simple, just from the output files of AERSCREEN, to generate a simple concentration versus distance chart, which is another type of chart that you'll be able to use within BREEZE AERSCREEN. But with the flow sector analysis, this takes a look at each of the 36 flow vectors, and it plots out either concentration or impact distance to that concentration, so that you can get a nice radial plot of which flow sectors might be causing you the biggest issues, so that you can start to look at maybe the layout of your facility and try and figure out how to prevent further issues from possibly cropping up when you move on to a refined modeling analysis such as AERMOD. So there's a lot of different output that you can get from within the BREEZE AERSCREEN application.